Hi everybody, welcome to the Applied Information Show. Today we're joined by Bryan Mulligan, who's the President of Applied Information.
Perfect.
And today we've got an exciting one, which is the future of transportation. And we're going to look back into the past, the present, and where we're going to be in the future. And we're going to do this very much in a conversational style session, where we're just going to talk about the different things and show a number of different items to you guys so you can see where we've come from, where we've gone, and what lies ahead of us. But before we get into this, Jessica, you've got a couple of items, and Jessica's not joining us remotely with video today, but she's going to be connected to the audio. Jessica, you want to come in with a couple of the items that that everybody's got to think about?
Yeah, so welcome to the show, everyone. We are live from the IATL. We want to encourage you to click speaker view in your top right-hand corner if you haven't done that for the best viewing capabilities. You should also see in your chat box that there is a YouTube link because Zoom cannot support HD quality right now. So if you would like the HD experience, you can just click on the YouTube link there. That is us. It is not spam or a hack. And if you would like to submit some questions to us, please use the Q&A. It's 2 thought bubbles on the bottom bar of your Zoom tools there. And that's it.
Yeah, and just, you know, as everybody's been growing and all the rest, what we found is Zoom struggles with these large sessions. So what they do is they do scale back the quality. So we're broadcasting live to YouTube. If you type in a chat in YouTube, we will also see those, and we can answer those questions as well. So Bryan, the past, the present, the future. You've been in this industry for quite some time, so you've seen a lot of different things. Do you want to tell us what we're going to be talking about today?
Yes, and I think that the idea of talking about this conversationally is important. So often we come across, this is you and me particular, as trying to sell something. We're presenting, we're projecting, we're laying out a program, and that we're trying to sort of force the pace. And what we're actually going to talk about today is in a way much more personal. It's not personal to me or you particularly, but it's much more personal to the people who are watching and viewing, because each of you are being faced with this problem of what should I do about the future. And so the way I thought about it is we've got 3 audiences that are watching, and there's the consulting community, and their role in the past, the present, and the future is subject to change. There's the cities, counties, and states, the end user community, and a number of you guys are watching, and welcome. But you guys are being faced with being tasked with doing more with less. How are you going to do that? And then I want to reach out and embrace our competitors who are also checking in and saying, what are this crowd up to? To embrace our competitors and say, listen, there's enough work for all of us. We've all got to get together and embrace this future, because there's a little story I tell that goes like this. He says, if you all think the pace of change is fast now, well, it's the slowest it's going to be for the rest of your lives. And so the pace of change is only accelerating, and that's frightening, because we like things to be more certain than that. And so hopefully what you're going to enjoy about today is we're going to take you through, in a measured pace, through a lot of stuff. We've got a lot of new things on the go. And what I'm doing is, instead of trying to explain everything about everything to everybody, what we're going to do is touch on each one of these topics, and we've got more than half a dozen, touch on each of them with the past, the present, and the future, with the idea that one of the things that we're going to look for from you guys is, what do you want a deep dive on? And then we can get into the business of a deep dive. And a deep dive is explaining in detail some aspect about the future technology. And I was very reassured by the feedback from our distributors. We had a distributor meeting last week, and virtually, and so we were broadcasting out of the IATL. And what we did is we did a survey on the different sessions, that what did everybody attending get the most value out of it. And what people got the most value out of was the session that Pete and I did on our new products, the future. So we got a real validation and a real data point that talking about the future is important, but talking about it in depth is important so that everybody can feel comfortable when we're talking about connected vehicles, that everybody has got a real sense about this or that, or virtualization or wireless telematics or whatever the case may be. We've got a lot of things to talk about. And so we're going to touch on each of them today, past, present, and the future. It's something of a travelogue of applied information and all the technologies that we're in and where we're seeing the future and so forth. But don't worry too much about trying to take on the detail of everything, because what we want to do is to feed back, there's a lot of discussion about latency in connected vehicles. Let's have a session on a deep dive on latency. I just picked a topic for whatever it is. But we can deep dive on any aspect of our technologies, especially as they're getting broader into more and more aspects of the transportation space. And so that's where I encourage everybody to ask questions and to help us. Hope you hopefully enjoy past, present, and the future, and figuring out deep dive.
And I think at the end of the session, we might just ask people to go in and type in, what subject they would like to go in a little bit more detail. In the next session we'll go into a bit more detail on, for instance, latency or school zones or whatever it is that we have.
Can be.
So, Bryan, I know we put down a couple of subjects that we wanted to go over. And we wanted to start off with one of the simplest things that we've been doing as applied information, which is school zones. And wanted to start off there and say, you've been in the industry a little bit longer than me. What was the past?
Okay, and so the school zones was these flashing lights that you see behind us have got a long and checkered history, and they fulfill probably the first of the really significant traffic calming functions. Why do we put up school beacons at all? And the answer is because those are the times that our children are getting into or off the buses, and the buses and the parents all coming in and out of the schools, and that's a high accident zone. So what happened with the school beacons, reducing the speed limit temporarily for an hour or two, whatever the case may be, had two effects. It had the effect of reducing the number of accidents, and equally significantly, the severity of the accidents. So that's why we did school beacons, and that's where it's kind of a uniquely American thing, that widespread use of school beacons in most states. There are some notable exceptions that don't use them, is to reduce the speed and the severity of accidents. You reduce the speed, so you reduce the frequency and the severity of accidents. However, that led to a bit of a challenge. So the first school beacons that were done electronically, and those were programmed by, and Peter's going to show some slides as we talk through this. Each school was locally programmed. So what you had to do in the middle of the summer, you drove around and you programmed each clock with the calendar and the schedule, and that was all very well, and they worked fine. They were the first. The first clocks were manually switched on by the school. There was a switch inside the front desk to turn them on manually, and then they had these things which were automatically programmed, and that worked very well, except when there was an unexpected event. There was an early release. There was a snow day. There was a
pandemic that hit.
The pandemic that hit. Well, that's been a real eye-opener, because the answer is, when does school start? And the answer is, nobody knows. And when does school stop? And what about Saturday school? And so that was the past, where all these things were manually programmed. It led to the the current status where everything's centralized in a cloud-based system. So all these clocks use cellular communication to connect up to the cloud, and that's something that we've very proudly played our part in, where it's much easier to change the timing of the school clocks. And the interesting thing about our customers, they've been some, in Gwinnett County, in fact, locally here was an early adopter of the technology, of our technology. And what they did is they found that there was a massive reduction in the number of complaints. And one of the most frequent complaints that a traffic department has is that the school beacons are going on at the wrong time. And this resulted in a 94% reduction in the first year that they ran centralized control. They could get their school clocks significantly more accurate and more responsive to the changing needs. So it delivered a real benefit. But everybody says, well, what's happening next? Well, that's the really exciting thing, is that these school beacons and the real safety benefits that they deliver have to be increased. There's still accidents outside the schools. So what the next thing is that the data of the reduced speed limit needs to get into every automobile. Every car and truck that passes the school needs to know that the school beacon is on. And so that's one of the reasons why we stood up the IATL, is to be able to collaborate with the automotive manufacturers, and it's under non-disclosure at the moment, but one of the automakers, leading automaker, is coming here to make sure that their motor vehicles react properly to school buses and school beacons, because they also perceive that this is really, really important as the future goes. And so there'll be some announcements about that in due course as we do the work and then publicize the results. But that's really exciting, because now the question goes not, should we interact with the school beacons, but how should we interact them? Should we apply the brakes? Should the default in the car be that that it automatically won't exceed the speed limit, or whatever the case may be? And that takes you to the lovely business called public policy, which is the politicians and the press and us as society deciding what should happen. But we're thrilled to be playing our part in that, and that's an example of the future. And so if you, my suggestion would be, if you guys are looking at doing school beacons, don't put in a school beacon that doesn't have the potential to talk to motor cars, irrespective of the technology, of the radio technology that's used, because that's where the future of school beacons is going to lie.
Perfect. Thanks, Brian. So what we're going to do is we're going to have a look just at a short little video that we've got here, and then we're going to have a look at some of the results that we've seen on how humans react to school zone alerts. So if you're ready here.
We ask enough of our educators. At Applied Information, we try to help. Like making school beacons easier to manage. Adjust beacon schedules from anywhere. Get customizable, smart alerts based on your criteria. Install is easy, and the beacons configure themselves automatically. When it comes to managing your school beacons, Applied Information has you covered. Managing kids, we don't really have an answer for that. But school beacons, we can definitely do school beacons.
So that's one of those videos that I just get a laugh out of it every single time I watch it. So but it is, the way of managing school zones has just become much, much easier with using the modern day technology. And what Brian was talking about, getting all these alerts into the vehicles, has been a very important thing. And we've actually recently just finished a study with the University of Florida. And they did a study on tracking people driving through a school zone and providing audible alerts and visual alerts that people are going to be speeding in a school zone. And what was the outcome of that study? So, I've got a couple of points over here. And what they did was they used eye tracking glasses that basically tracked what the people's eyes were doing, and they were looking at the driver's speed as well. And what they found, interestingly enough, was that only 50% of the people see a school beacon, a flashing beacon. Only 50% of the people. And they found that when they put in connected vehicle messages, in other words, audible alarms that someone's speeding in a school zone, it decreased this probability of them speeding, and also at the same time increased their visual scanning of the roadway. And they were seeing anywhere from a 2 to 36% reduction in speeding with an average of 15%. I mean, that's a huge amount of reduction. And obviously that's an independent study that was done by the University of Florida, really showing how connected vehicle messages, and this is the idea that Bryan's talking about, is when you can get these messages not only in a smartphone, but directly to the car. What are some of the life-saving benefits you're going to see there?
Yeah, and I think that that's where, when we talk about pedestrians, you're going to see the data related to the speed of collision and the survivability. And so 15%, to go from 40 miles an hour to 34 miles, 3 miles an hour, whatever it is, results in a significant increase in the survivability of a collision. And so that's where huge. And I think that that's where we really positioned to use these technologies to make a real difference in the future. It's just starting. It's going to make a massive difference.
So we want to go through this quite quickly. So that's touching on school beacons. Let's touch on...
Let's go faster.
Let's touch on emergency vehicles. So that's one of the other technologies that we've been involved in. And let's maybe look at how it was done in the past. Maybe you want to just explain a little bit of what emergency vehicle preemption is and how they used to do it.
Yeah, emergency vehicle preemption has been around for a while, and that's the business of creating an environment where the emergency vehicle gets a green light and everybody else is safely brought to a halt. And that was pioneered by a company called Opticom, really, that did it with an infrared transmitter on the vehicle and an infrared receiver on the mast arm to receive a signal to say that an emergency vehicle is approaching from that approach, and that it would give it a green light. And so traffic controllers have been programmed, have had the capacity for preemption for many, many years. However, the big problems were that you couldn't do around the corner, and things got in the way. You couldn't tell whether it was working or not. And so that led to the next iteration, which was called GPS, where the GPS position of the fire truck relation to the signal was measured and then transmitted over a radio. And so various radios were used, but they were all line of sight radios, which resulted in improvement in the performance of the preemption system, and were quite widely adopted. We came in really with the new innovation, which is what we call round the corner and over the hill, which this little slide shows. And so what you can see is a lot of road, and here I'm sitting here in Georgia, and that's there isn't a road here that's straight for a.
And this is Marietta.
Okay, so that's Marietta, and so what you can see is that each one of these traffic signals is around the corner from the previous traffic signal, and when the emergency vehicle comes down requesting a green light, line of sight radios just don't do it. So what we did is that we bounced the radio signals not only with a line of sight radio, but also up and down over the cloud. And that really transformed the industry to adopting redundant radios or dual line of sight and cloud things. And that was where we really figured out that connected vehicles are going to need both line of sight radios as well as cloud radios. And that's been quite interesting. We're going to talk about that later. But there's a real deep dive into what kind of radios you should use. And now we use you know, for those who've been watching us, any kind of radio. So we use Wi-Fi radios, we use cellular V2X direct radios, we use DSRC radios, and we use cellular V2N or cloud radios. And they all work together to get the message from the fire truck or from the ambulance or from the police vehicle. Interestingly enough, the police vehicles are starting to use this technology more extensively, because it makes a fundamentally safer world when you get a green light and everybody else is safely brought to a halt. And so that's the present, where we've really, you know, got this new paradigm of multiple radios. What the future is kind of really exciting, which is where every vehicle, you know, when you're standing there at a traffic light and whoa, 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 and you go, oh, where's that fire truck coming from, the right, the left, and your car speakers say emergency vehicle approaching from behind or from the right or from the left. And when your cyclist gets an alert that there's an emergency vehicle coming and he better clear off the road. When the pedestrian on the sidewalk is told stand back, there's an emergency vehicle coming. So emergency vehicles and preemption are just what we call a day one application of connected vehicles. It is low-hanging fruit to show the benefit of connected vehicles and save lives today. There's a great study, if those of you interested, you can ping us and ask us for it, which was a medical study about the 365-day survivability of the time of arrival of emergency medical help. And it showed that there was a huge benefit in survivability. Hundreds of thousands of lives per year can be saved by making the fire truck and the paramedics get to where they're going a minute earlier. So this is not something we're sucking up out of our thumbs, but there's data behind it to say that emergency vehicles as a connected vehicle technology saves lives. And we're just getting started. There's the new products and the new you know, technologies of being able to support, you know, future radios. It's all being shipped right now. This is the you know, our new 06502 devices, which support up to, you know, 4 different radios, and with pluggable slots, so you can be absolutely future-proof and deliver these messages to the connected cars which are on their way.
And we've seen some really great studies come out of, like, for instance, City of Marietta, that have shown a 60-second to 90-second improvement in response times. And recently, the City of Alpharetta have shown an 18% improvement in their response times, which is huge. I mean, it's, you know, this is that day one application that you can really help start saving lives. I've got a short little video over here that we're gonna showcase on emergency vehicle preemption.
When you're having an emergency, every second matters. At Applied Information, we want to help. We created an emergency vehicle preemption system to help save first responders 11 seconds per traffic light, meaning they get to you faster, safer, and ready to help. Want more information on the system? Download our free info kit today or give us a call to set up a consultation.
And just before we move on to the next topic, there's another key thing that emergency vehicle preemption gets you, which is not obvious at first sight, because so often emergency vehicle preemption systems are done with the fire department and the traffic department in agreement to deliver emergency vehicle preemption. But exactly the same technology and approach gives you transit signal priority. And exactly the same signals and approach gives you safer cyclist system. We're going to talk on that a bit later. But one of the things that we suggest is that when you're thinking about connected vehicles and emergency vehicle preemption, it's just day one application, saves lives, improves traffic today, but there's all sorts of applications for it in the future. Using the same technology, there's no more hardware to install, It's all, you know, I mean, that might be something for a deeper dive. How do you actually connect up a emergency vehicle preemption system so you can make cyclists work better, or transit, or virtualization, and we can do a deep dive into some aspects of that, perhaps.
Yeah, and that's one of the great things, Brian, that's really important is, and this is something that we always say, competitors, all those kinds of things, all of the people that we work with, critical thing. When you're in the traffic industry, you have to have over-the-air software updates so that you can continue to improve on the technology, make it better, because, well, frankly, we don't know what tomorrow's applications are going to be, or the application in 4 or 5 years down the line. But if you've got over-the-air software updates, you can go ahead and update things.
Yeah, and to give you an example, who saw scooters coming? No, I mean, I'll go first. I had no idea. I had no idea that scooters were a thing. I mean, who would do such a thing? And suddenly they're on every sidewalk everywhere. Now, should you have separate lanes? Should you have separate phasing? Should you make your scooters actually start 3 seconds before the light changes so that you can avoid those right-hand collisions of people, you know, going into the scooters? The point being is that all of these things are all part of the future where the applications are unknown. We're delivering platforms these days, like your smartphone. Who would buy a smartphone that didn't update its own, that its apps couldn't be updated? Just a key part about how we think about the world. And we all in the traffic industry have to adopt that we're going to deploy platforms on which we're going to deliver applications as we go forward.
Great. So what we wanted to do is talk about the next item, which is connectivity. And connectivity to traffic cabinets and all of these types of devices in the traffic industry. Brian, do you want to talk us through the past? And don't give away your age right now, but.
Well, yeah, connectivity is an interesting topic all by itself. And you know, when we started in this traffic business, it was all twisted pair. Well, let's go back a system. Before the electronic traffic controllers, there were these rotary drums with a cycle timer, which was that literally because that's how long it took the thing with the pins in it to go around. And so even those ended up being connected together. But where we really started was with modems and twisted pair and FSK modems. And so we'll throw up a slide of a thing that some of you might be familiar with, and that noise that it made. And at that time, you thought that was forever. Nobody ever contemplated that modems wouldn't be with us forever. Actually, and there was an interesting story from Hayes Microcomputer, which was here in Atlanta when I first moved here 25 years ago. And we hired a guy out of the marketing department of Hayes Microcomputer, which had sort of ended its life. And what the guy was telling us the story about how he did a deep dive into who used 1200 baud modems, because in the days of 56K modems, who would continue to use 1200 baud modems? Because they wanted to kill the product line. And they found that there were two industries buying 1200 baud modems. And one was the traffic industry, still using 1200 baud modems to go from traffic light to traffic light. And the other was bowling alleys to get the scoreboards connected to the thing which picked up the bowling pins. And those were the only two industries that still use 1200 baud modems. But as you know, in the fullness of time, those have all gone away to be replaced by what we see now, which is fiber. And a lot of cities figured out that the way to join up all the traffic intersections more reliably was with fiber optics. And so indeed, that's been a whole business for a number of years, putting fiber in the ground and with a lot of success and a lot of connectivity. But a typical city in our experience, on a maximum basis, has roughly 2/3 of the intersections connected. And there's always 1/3 that are out there that are really difficult and expensive to connect on fiber. And so the other thing people are finding is fiber is difficult to maintain. To bespoke fiber, when it's only used by the traffic department, consumes a significant portion of the budget to maintain that every year, let alone roll it out, because it's all just very expensive to roll it out. So the future, and is ended up that where that is in wireless. And last mile wireless is just taking over all sorts of areas as we speak. And you can do video over wireless. A couple of years back it was all bespoke proprietary wireless technologies of various types, which work, but again, they were another thing for the traffic department to maintain. And now we end up with a situation where the world's been covered with cell phone radios and receivers, and now Starlink radios and things which are low Earth constellation internet providers. And all of those provide the last mile connectivity at a fraction of the cost of owning it yourself. And that's where we've tried as Applied Information to be playing our part in that, with each one of our devices obviously has a radio in it, which you can use to establish a virtual private network into the traffic cabinet. And so that might be something worthwhile as a deep dive, is a comparison in cost between putting your own fiber in versus using wireless fiber, as we call it, and how we would do that with what ends up being a shared service, where you're not only providing traffic data but other data over the same circuits, and that obviously makes a fundamentally less expensive solution.
Yeah, perfect. Bryan, why don't you walk us through and show us just some of this functional art over here.
All right, okay, this is quite funny.
Just because this shows, where all the wireless communication's going and how it's rapidly changing.
Yeah, this is a piece of art on the wall here at the IATL, which just shows in the last 7 years, when we started off, it was all 2G. And this is a 2G radio, which was the state of the art at the time. That then moved to 3G, and we got a number of turn down notices, that 2G was being turned down. And so what we ended up doing is, that you can see our design is that all of these wireless devices all come on clip-on plug-in modules, and that is because we understand that the radios are going to change roughly every 18 months. Every 18 months there's a new radio, and it goes to the standards, the 3G, 4G, 5G standards, which are produced by the 3GPP. And so they produce a new release roughly every 18 months, which is how the handset works, the handset market. And so we, latching onto the back of that, and that just shows a variety of radios. There's a Wi-Fi radio. 4G LTE has been a standard for a while now, but even 4G LTE has got Cat 1, Cat 2, Cat 3, Cat 4, Cat 1M, and all of these things provide different services, different bandwidth, different features, and different power consumptions, which is leading us to be able to deliver new products. For example, where we can provide a product that can monitor your crash cushion, but it can last for 5 years on a couple of AA batteries, because we can make now these communication devices work on the amount of power that's used by the heartbeat of an ant. And that's my little joke for how much power these things can use. Cellular VTX and DSRC are also pluggable modules. We've got some little show and tell that we can show how that you can make these things pluggable, so that as 5G and 5G NR and the things that you hear about, you're going, well, how am I ever going to get on top of this? And one of the things, in fact, I give a shout out to Winter Horble, who raised during a dealer meeting, is let's make all our fire truck devices being able to accommodate these different radios. So we'll sell them with just the 2 radios that we currently sell them with, but everybody says, well, what's going to be the radio of the future? And we can give a warranty that says no matter the radio of the future, cellular V2X direct, DSRC, 5G NR, doesn't matter, we'll keep you future-proof by having pluggable radios. So that might be something for folks to think about, is that if you're installing any kind of application, then buy one that's got pluggable radios. Pluggable radios are just a good thing to do.
Yeah, that's absolutely awesome. You know, I mean, I think what is important is what we do as well, and what is important is if you buy something like this, make sure you get it that the company that's providing it to you will actually upgrade the cellular modems as part of their service plan, because that's a key thing. Is we should be providing cellular communication as a service, which means upgrading those little modules, what Brian's got in his hands over here, you know, upgrading these little modules. You can see it's a small little module. It's not a huge cost, so it should be part of your connectivity and support plan.
Yeah.
All right, Brian, but we're touching on all these different subjects, and we're trying to rush through this as quickly as we can. The next thing that we've got is pedestrian and cyclist safety, which I know is, you know, is near and dear to all of our hearts. You know, trying to reduce the number of accidents, you know, of these pedestrians. And you talked about this a little bit earlier, Brian, about slowing down the vehicles. Can you explain it a little bit more?
Yeah, it's hugely important when you consider pedestrian safety, the speed of collision. And this could be a deep dive all on its own. For example, the city of Atlanta here is a key part of their Vision Zero, is how to reduce fatalities, is to be able to reduce the speed of vehicles in cities. And so one of the things that they've done is just reduce the speed limit throughout the city of Atlanta. This statistic over here, this slide over here, really tells the story that if we have a pedestrian vehicle encounter at 20 miles an hour, there's a 90% chance of the pedestrian surviving. If we have that same collision, but at 40 miles an hour, there's a 10% chance of the pedestrian surviving. And as we go through the statistics of the thousands, so I think it was 7,000 vulnerable road users which lost their lives last year, it's just a massively important thing to reduce the speed and the frequency of collisions. And that's where we can make a big difference. So in the past, how that worked is everybody just, you take your life in your hands and you head off. Yes, you're not supposed to jaywalk. Everybody jaywalks. You know, walk down to the traffic intersection and press the button and wait there. But one of the things that we've learned is that pedestrians aren't very good at being responsible for their own safety, and that the people crossing mid-block is just a thing. And so that's where the present is to do a bunch of mid-block crossings like RRFBs and hawk signals to provide pedestrian crossings where the pedestrians want to cross, not try and make the pedestrians cross where the traffic engineer wants it to cross. So that's probably been the biggest paradigm shift from the past to the present, is to make people, to understand that people aren't going to take care of their own safety. We as engineers and practitioners, we have to take care of people's safety, and that we're doing by providing the crossings where people want to cross. When we jump to the future, well, this all becomes really interesting. So what we'll do is we'll take a little bit of a walk down to another part of the IATL here. And this goes to the business of what does it look like when everything's connected to everything and it changes everything. And so what we'll see is here's an RRFB, which is a normal RFB, but we've extended this RRFB to have a dynamic message sign, which is an extra visual element to be able to give pedestrian, not to give the approaching vehicle, another individual indication that there's a pedestrian in the stop walk. I'll turn that on again. And that's just powerful because this is all user definable messages. We can make that message flash, 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 flash. We can make it change if there's a pedestrian in the crosswalk and we detect a speeding vehicle. So there's a whole bunch of things that we're adding to the units, and it's a normal unit that looks like this. But this has the capability of having a radar which measures the speed of the approaching vehicles, an inexpensive Doppler radar. And that's what gives the indication when there's a pedestrian in the crosswalk and there's a speeding vehicle which we're detecting and that it's not going to stop. Well, we can give this audible alert through the push button or through a speaker to the pedestrians in the crosswalk to say, bop, bop, speeding vehicle left. We also give that same audible alert inside the car, and this is a key application of connected vehicles. Don't worry about the radio. Don't get all hung up about the radio, but this is an application for getting that there's a pedestrian in the crosswalk and we're detecting in the car, in the vehicle, that it's not going to stop in time, and by doing that, we'll save a significant number of lives because that'll make both the pedestrians more responsive, as well as the vehicles more responsive, as well as the driver more responsive. And by doing that, we can, that's where the future lies. And so as you're looking at increasing your mid-block crossings and so forth, have a look at these things. And this is where, buy your products and your systems and solutions that support these kind of technologies going forward, because that's where it's going to be. Yeah, Pete, anything more?
Yeah, I mean, there's, on the pedestrian and the cyclists, I think one of the other really important things is, another study that was done by the University of Florida, which looked at the cyclists and collisions with cyclists. So they used the Travel Safely Connected Vehicle application with the eye tracking glasses to track where people's eyes are looking at. And the interesting statistic that came out is, on average, only 16% of people see a bicycle. Now you know why there are so many accidents. And when they put in the connected vehicle messages, that number increased from 16% to 50%. So 50% of the people then started to actually use their eyes to track exactly where the cyclists are. So the increase, the increase in terms of people being aware of cyclists is drastically improved when you're using connected vehicle messages. And that's one of those technologies that I think is really important. It's an application actually showing how people are actually the safety, the vision zero can actually be achieved.
Yeah, we're busy doing something else with cyclists at the moment. We've in fact got a job out in California, and we're piloting that here in Alpharetta. But what it is, it's the next level of what do you think about them apples kind of approach, which is, how do you as a mayor give respect to the cycling club in your city? How do you make cyclists fundamentally safer? Well, as it happens, you use the same technology that you use for your paramedics, but it works like this. Obviously, what's a problem is that when an individual cyclist comes up to the stop bar, often the loops don't detect a cyclist because there's just not enough metal in his high-speed aluminum racing bicycle. So using connected vehicle technology.
Aluminum? Come on, Brian. We got carbon fiber these days.
All right, well, there you go. Well, a magnetic loop picking up carbon fiber. I mean, okay, even worse. Just shows how old I am. But when the guy's got his connected vehicle device, which is his smartphone in the first instance, in his pocket, it puts a call into the traffic intersection to say that there's a cyclist there, so he doesn't wait at a red light, it services him as expected. But when there are 2 or 3 people cycling together, what it puts in a transit signal priority call to see whether it can shift the phases around, to see whether it can get those 3 cyclists through the light without them having to stop, because when they're going, it means that everybody else is stationary. That's just fundamentally safer. And when your cycling club and your peloton comes along and you define that as 6 cyclists in a group, in this size group, it actually pulls a preempt. And so what it does then is that it absolutely gives the cycling club on their Saturday mornings the run of the city when they're cycling together, and brings all the other traffic safely to a halt so that they don't hit the cycling club and cause an accident. They don't overtake it. They don't. The way that they get through stoplights is just effortless. And so that's an example of using connected vehicle technology to deliver all sorts of applications
and we hadn't even thought of that.
We hadn't even thought of that. And what's exciting about all of that is how well is it going to work, is the question. And the answer is I've got no idea. But what we do know is that the technology works. We can group the cyclists together. We've got all that. We get all their messages that they're cyclists through to the traffic controller. We process it against a set of rules and decide whether to pull a preempt or a TSP or a call or whatever the case may be based on your local public policy. But the great thing about it all costs no money. It's just a case of configuring it. There's no extra hardware to install. And it's a great example how when everything's connected to everything, it changes everything. Now, if it works really well, expect that to be a national standard. Soon is that there's, cyclist advocacy in any city is a powerful force. And so what we do is that this allows you as a city to be able to deploy some of these advanced technologies if you just buy the right equipment to start with.
Yeah, and this gives you this is a short video here that I did. This is me cycling. So you'll see this is actually cycling up towards the signal, and the signal's 60 seconds before it changes. There's travel safely on the left-hand side. And as you're cycling up to the approach of the signal, we connected to the traffic controller, and we're going to place a priority call here, and you'll see the call coming through there, and you'll see the timer on the left-hand side actually changing, and before the cyclist even arrives at the traffic signal, he gets a green light. So, the signal goes green before he even arrives there, whereas previously when I rode up to a traffic signal, I wouldn't get detected at all because it's a carbon fiber bike, as you said, won't get detected by those loops there.
So all of this is, again, the past, the present, and the future. So that's pedestrian cyclist safety. There's a lot of work. The whole topic of vulnerable road users, just really, really interesting field for us to deliver real benefits, right now. It's just limited by imagination.
Bryan, before we actually go on, I wanted to actually check in with Jessica if we've got any questions before we rush over onto the next subject. Otherwise, we might just continue and not answer any of the questions. Jessica, are there any questions over there?
I was wondering when you guys were going to call on me.
Sorry.
When we stopped
we got carried away there and didn't.
No, it was fantastic. I haven't even seen that bicycle one, so that is super cool. Okay, we have a couple of questions here. The first one is asking which cities in the USA have the most use of connected vehicles, technology, and use of the Travel Safely app?
It goes from widespread to nothing at all. So I think that in the city of Atlanta here, certainly we had a number of early adopter cities like the city of Marietta who went first. The city of Atlanta, the North Avenue Connected Vehicle Corridor, Smart Corridor project, they saw the benefit of connected vehicles and travel safely really quickly. It's extended down to Florida, but that's all over the place. Alabama, we've got
University of Alabama.
We've got a lot of work going on there, and the Carolinas, in Virginia, up into Maine, Connecticut, and then equally from east to west. The interesting thing that I would say, perhaps politically awkwardly, well, yeah, in other words, going west, Hawaii is a leader in all of this. The slowest place to adopt it is California. And that's, of some interest is why is California? And our answer is I don't really know. But that's been slow to adopt because there hasn't, up until now, and I'm talking, from the US DOT through to the states, there's been a real focus on the radios. And now we have an argument about the radios and we fight each other to death about the radios. Now we've got the whole uncertainty created by the FCC, which is probably worth a deep dive all on its own. What does all of that mean? But people forget that the whole idea of these radios is to actually deliver applications. And the areas that we've been strongest has been in cities that have been receptive to the message. Let's actually solve the problem. It's actually a bit of a segue into a next topic, but anything else?
Oh yeah, you don't get off the hook that easily. Okay, so we have someone asking, have you connected with bicycle advocacy groups? If so, what has been the response?
The response has been mixed. Full disclosure.
But we have this application that we just showed the video right now. That's obviously brand new. We haven't actually connected with any group on that new application about providing green lights.
Correct. I'll just say that there are two types of cyclist advocacy. And those that are, and we've got a number of interactions with a number of these cyclist group who, say, yeah, we all got to participate in finding a solution. There's the scooter groups and various other groups. I will say that there's some cyclist advocacy that says any money that is spent on doing anything else about building us our own cycleways is a waste of money. It's quite a powerful lobby that says we're not interested in any of this stuff, just build us our own asphalt. And so we do encounter that, and we obviously don't build asphalt, so we just say, sorry, we can't really help you with that because we're not in the asphalt business. And so there's certainly some outbreak, and that's where we're looking for some of these pilot projects that we're doing now, and in fact a city project in California, is to point to it and say, okay, there is a solution where the cycling club is being kept safe, and it's at a fraction of the cost of building new cycleways. So those are the two groups, and we engage with both of them. Jess?
Awesome. We have someone, people are really about these bikes, y'all. Do the mobile bike apps connect to a cloud server or directly to the traffic controller?
It passes through the cloud server. And so that's a whole topic all on its own. How we do that is called the Travel Safety Data Exchange Service, where we send data from anywhere to anywhere based on a set of rules. So the cyclist's data ends up at the traffic intersections that are immediately in front of them, as opposed to sending that data to the whole city and things like that. It's quite a data exchange services, or data routing is quite a sophisticated thing. And so we route that through the cloud at the moment. And that's all anonymized and privatized. And so we make sure that we don't track who you are and where you're going and so forth.
And the cool thing with that actually is when you're cycling, like I cycle early in the morning, and there's no other cars on the road, but I get to red traffic signals and I have to stop, and there's literally no one else in the road. Whereas what this does is it tracks your speed that you're driving and your estimated time of arrival, and puts in a detector call 13 to 15 seconds before you arrive at the signal. So by the time you get there, the signal's green. That doesn't include any priority or anything like that, because those controllers are all running in free actuation. So it's a great way of actually just, if you can, as Bryan said, if you can connect everything to everything, there's so much more that you can do with that data, and applications are endless there.
Correct, and that's the big trick, is to be able to deliver these applications off a platform. And so one of the things, just to be in full disclosure, is that it is possible to connect the phones directly to the traffic signal. And that's called the brokered connection, where you've got the system that acts as a broker. And that's how Skype and Zoom and these other things work. But that's a future time when there's so much data traveling around the place that you need to do it. It's probable that that will never happen, and the reason why it will never happen is because the amount of data that we use with these little messages, tiny little packets of data, and it's all swamped by video. All of you guys watching on Zoom and so forth are using massive amount of data to see videos, and so broker connections are possible, but unlikely, and the data exchange services are probably the design that's going to prevail for the next 20 years or so.
Jessica, over to you.
Yes, someone is asking, is it possible using the Travel Safely app for first responder vehicles to request and change of the traffic signal lights or extend the traffic signal lights?
Not from, in other words, what we always recommend, in other words, yes, it's possible, but we recommend having a physical piece of hardware where it's tied up to the emergency lights.
And there are two reasons for actually putting a physical piece of hardware in the fire truck. The first one is that you've got redundant radios. Then you've got both line of sight radios as well as cloud radios. You've got long distance communications, short range communications, but redundancy. And that's made a fundamentally safer and more reliable preemption system. The second thing is that there are a bunch of wires in the fire truck that you need to connect to. You need to connect to the overhead lights. You need to get to the left indicator, the right indicator. You need to connect to the emergency brake. You need to connect to the door switch, and so forth. And your phone and Travel Safely just doesn't have a place to plug in those wires. And so you'd be making a harness which tried to connect to a phone, which is not really an industrial wide temp piece of equipment. So that's why we recommend for emergency vehicle preemption, put a box in the device. But for transit signal priority and cyclists and things like that, no, then you don't have to put a box in any of those devices. You can use a phone. In fact, our freight priority application, which we call Travel Safely Pro, uses a phone as an OBU to request priority for freight vehicles in off-peak periods, drive the behavior that everybody wants. Connected vehicle technology makes your freight vehicles go through traffic lights more easily in off-peak periods, gives an incentive for the trucks not to be in rush hour.
So we've got time for about one more question before we're going to wrap it up and talk about what we missed out in this session.
Yeah, in fact, it's actually been fantastic. I mean, we wrote out a schedule of things that we might talk about. Before we get to the last question, I'll just touch on those. The whole business, so you can see that we focused on the low-hanging fruit, the products that we're in, the markets that we're in. We haven't talked about any of our future products and where the market's going in the future with widespread low-power monitoring and with virtualization and so forth. So what we maybe should
2 weeks time, Brian.
2 weeks time. We'll do a past, present, future part 2, but also talk about at that time the method of contract. The traditional method of contract that we as suppliers, consultants, and cities have used, where the cities buy assets based on the civil engineering method of contract. Those times are changing too, and we'll touch on that and what NASA's doing and various other things. But that's past, present, and the future part 2, which will be in 2 weeks' time. Jess, what you got?
Okay, well, we have lots of questions here, but we will cover those in part 2. And I think this is someone from a city or agency that has Travel Safely already. How can we encourage more of the people in those cities to download Travel Safely app and actually use it?
Great question. And that's, I think, the topic. I mean, it's a broad topic. Maybe that warrants a deep dive all by itself. And what it's to do with marketing and promotion. The business of, if you want to change the behavior of the public, particularly with regard to safety, It involves advertising. It involves marketing. It involves repeating the message over and over again. There's one thing that we've learned in the traffic industry and in the automotive industry, that people don't naturally gravitate towards safety. It's just been a thing. That, for example, when seatbelts were introduced and when airbags were introduced, nobody bought those. Nobody wanted safety, because one thing we know about accidents happen to other people. They don't happen to us. So travel safely falls in that category, even by its name. People, it works really, really well. But I think that we and the cities that have it, we need to talk to them, and that's Bill Wells, our VP of Communications. What does a communications program look like? What does a public outreach program look like? What does it look like to be supported by your social media presence and so forth? What does it look like to give prizes to people? And
yeah,
so on.
And that actually came in how the Dutch did it.
Yeah.
You know, they provided an incentive, so they actually paid people to download the app and use the app for a year. And well, they got 27% of all people on the roadways connected because they paid them to get connected. But now all of a sudden, they got a massive data. They don't have to deploy Bluetooth devices to track where people are. You know, there's just a huge amount of data that's now available to them. And actually the cost wasn't that high then in the end.
Yeah, in other words, so all of these things, so that's where, if you're a travel safety city, let's reach out to us and let's have that discussion. Leading the way doesn't mean just with technology. It means with the reorganizing how we interact with our public. And that's the next thing that we collectively can work on is further outreach of travel safety.
Bryan, I think we'll just stay on for another couple of minutes just to see if we can go over any of these questions with
I think we should try and do that. Let's try and do that. We're not in any rush. I know that you guys are on the hour boundary. We've just gone through our hours, so I'd just like to thank you all really, really for joining us and listening to the past and the present and the future. And we'll
send out a YouTube link that you can share with anyone as a follow-up email, and we'll also follow up with another invite for the next session in 2 weeks' time, where we're going to go through more of the future products, which we didn't quite get to. I think we got carried away with the existing ones.
But I think it was really good to just have a gentle conversation about all of these things. Because if you go through everything too quickly, it's again, bop, 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 and then, what did Bryan say? He said something about NASA? What was that about NASA? I didn't really kind of understand what he said about NASA. So we'll touch on that next time and then do a deep dive. So thanks everybody who has to drop off. Jess, what's the next question?
We have someone asking, are there any plans for Travel Safely to use the CV2X PC5 of mobile in the future?
Sorry, I've missed it.
Any plans for the Travel Safely app to use PC5 in the future?
And the answer is yes and no. The reason why it's yes and no is the Travel Safely would use PC5 just as soon as a phone supported PC5. That's something that we can maybe do as a deep dive. We've got Travel Safely connected via PC5 to traffic intersections right now in the lab, but it involves having a PC5 receiver which connects to the phone via Bluetooth. So that's an infrastructure market adoption kind of thing. The business of the collaboration with the auto companies and how travel safety gets incorporated in the cars is a topic. We've got relationships with a number of the auto companies where that is being discussed. And so that's something that's beyond our pay grade, is when the phones are going to include PC5, because that's something for Apple and the various phone manufacturers to figure out. But we are part of the 5GAA, and so we're keeping our eye on all of that. And but I would say that's a number of years away. There's no imminent thing that the phone's about to come out with PC5.
There are a couple of phone manufacturers, LG and Samsung, that are testing out PC5 in the phones, but there's nothing commercially available on the market yet. So when that does become commercially available, well, Travel Safely communicates the nice thing with Travel Safely is it's an application that's communication independent. So whether it's communicating over Wi-Fi or Bluetooth or cellular or in the future PC5, it will use any of those. So
yeah. And the interesting thing for those just a little bit more technically, how do we actually do that? We don't arbitrate between those messages. What we just do is, and we've got a lot of experience in doing that now, each of the messages are numbered. And we send the same message over all the different radios. So in Hawaii, for example, we're sending the messages over 4 different radios. And in the intersection, we just process, or in the phone, we process the message that arrives first and then discard the rest of the messages. So that's why whatever radio gets the message through first, we process that, and then the other messages are discarded and we wait for the next message. So it's actually quite straightforward on a computational state machine basis to use multiple radios, because you don't have to decide which one's working, which not. You just listen at all of them and then process the message that arrives first.
Jessica, over to you.
All right. Someone asked, what detection technologies, loops, radars, videos, etc., are compatible with your connected solutions?
And the answer is all of them. So I'm going to give you the short answer, not the long answer, because the long answer is to do with abstraction. And abstraction is where you have a layer. And how do we build the internet? How do we build these technologies that we use every day in the phones and so forth? The key concept is abstraction, where there are these layers of functionality. And so what we do is that the way the detectors all work is they all result in a call which says that the vehicle is there or not there. And so they all work with Travel Safely. And so we know that Travel Safely, let's say, does a pedestrian detection. We have some video detectors that do pedestrian detection. We don't care what brand of pedestrian detector it is. They all put the call in the same way. And even if they don't put it in the same way, some do it by means of digital inputs, others do it by means of protocols. The way we do it is we've got a driver in our software that deals with all these field devices. In fact, we've got a family of drivers. Based on a configuration file, it would know to deal with this kind of video detector or that kind of video detector or this kind of loop or that kind of intelligent push button and so forth. And because we've got all these individual drivers, we can support all of them confidently.
And obviously there's NTCIP standards as well, which allow us to communicate to controllers utilizing that kind of standard.
Yeah, and so NTCIP, I've obviously been the NEMA NTCIP head of delegation for many, many years, and so I'm very, very familiar with the NTCIP standards. And even if somebody doesn't get the NTCIP standard quite right, we don't really mind. These things happen, and what we do is we write in our driver that this guy's flavor of NTCIP is slightly different to that guy's flavor of NTCIP, and then we just make it all work.
Jessica?
All right. This one says, what are your thoughts on induced demand? Will the travel time benefits of ITS be temporary as more and more people drive personal vehicles because the technology improves travel time, and after a lot of people you get crowded again? Or do the safety benefits, or is it more about the safety benefits that never go away?
No, I've got a third option, which is this. I mean, the interesting thing about travel demand is that the one thing that we've shown is that for 100 years, we built more roads. That made people buy more cars. We got more traffic. So what we did is we built more roads, which made people buy more cars, and we got more traffic. Until mobility, and in fact, we've just shown over and over again that that building our roads is not going to get us where we need to be. So, and then that's the travel demand problem. The safety problem is that nobody buys safety because accidents happen to other people, as I've said. So I don't subscribe to either of those views. I subscribe to a third view, and that is this, that we as a society need to balance efficiency of safety. I don't believe we have to choose one or the other. What we could do is choose both. Safety, and the safety is going to come from us, our political structures, our city councils, our state governments, our county governments, who are going to, in the common good, regulate safety. So fine, we talk to those people over there. But let's, on the left-hand side, talk about efficiency. So connected vehicles and these technologies, in the first instance, traffic controllers moving to trajectory-based approach. That has showed some promise. But the real low-hanging fruit for reduction in congestion is multi-passenger vehicles. And this is something that there's comparatively little work being done on in America. A lot of work being done in the rest of the world. And I'm from South Africa, you can tell from my accent. And interesting thing about South Africa, you know, people stopped me. I was speaking on a talk somewhere in Brazil, in fact, and they said, "I heard about South Africa. How on earth does the bus system work in South Africa?" Well, I said, it works like this: that the bus system consists of 10 passenger, privately owned, unregulated, unrouted, unscheduled buses, and 5 people on the bus, and the bus is behind schedule. That's fine. Works great. Off we go. Gives transit signal priority to the buses. Elsewhere in Atlanta, they say, no, our public policy is this. Always give the buses green lights. Effectively give them preemption. Because what will happen is that if that single occupancy vehicle sitting at the side streets sees a bus come through, an empty bus come through on the green while I'm held on the red, well, then maybe tomorrow I'll ride the bus. So I think that there's a lot of work to be done in multi-passenger vehicles, and this all ties into autonomous vehicles as well. There's a lot of last mile discussions using autonomous vehicles to do last mile routing from more mainline transit and so forth. And I think that where the answer lies and the future lies, this blend of technology, electronic BRT, bus rapid transit. Let's not build extra lanes for the buses. Let's just make the lanes that the buses go in, just make that lane go better and inconvenience everybody else. We'll soon all be riding the bus.
All right, Jessica, any more questions?
I think we are good.
All right, just checking, because we might have had, we probably only have one person still on.
Yeah, I think everybody else has dropped off. It's just me and you talking to each other, Pete.
We have 47 participants, y'all.
Oh, well, thanks you guys for hanging on and chatting with us as we explore the past, the present, and the future.
And look forward to your invite that comes through for 2 weeks from now, where we'll do the next session. So thank you very much. Appreciate it. And thanks, Bryan, for joining us.
I appreciate it. Thanks so much. See you guys later.